So do you see me recording? Does anyone get the notification?
Yes.
I want to be sure. Okay, so welcome again to today's section as we'll be going more into Kubernetes, and I'm sure you're going to enjoy it today. So before we start, I want to implore us to subscribe to my YouTube channel so you'll be able to get more notification whenever I post new videos. So my YouTube handle is Oluwasegun Adesanya, so drop it in the chat so you can just follow me on my channel, and because I'm trying to create a community, and maybe I don't know, maybe from next class I'll not test it. Probably we'll be doing a live section on YouTube instead. So let's begin. So yesterday we talked about the Kubernetes architecture. We talked about the pod, and we talked about the context we are using. We talked briefly about Google namespace and co. So, but then I just want to do a quick recap on what we did yesterday. Okay, I think I didn't need this. Just a moment. Okay, you can see this architecture, right?
Yes.
So yesterday when we talked about the Kubernetes architecture, okay, this is okay. Then don't worry. So just forget about this service you are seeing behind. So let's just want to make a quick recap on this architecture so you're able to refresh your memory and understand what I'm saying. Now, coming back to this architecture, we talk about microservices and others. I just want to make a little emphasis on what these people are doing as they relate to this. I said this API server is the heart of Kubernetes. When you are talking about container orchestration, all those big names, this is what we are referring to. The API server. So like I said yesterday, is the mid feeder. So it's the one that accepts the request, it will authenticate it. So the moment this guy accepts the request and authenticates it, the next thing it will do, it will send a signal to this etcd. I said yesterday that this is a database, like the storage. Database, let's use it that way. So it will send, is the only one that communicates to this etcd. Is the only one. So immediately there is a request, it will authenticate it. Like, okay, for example, when we use kubectl get nodes on our terminal, kubectl get nodes, what we're actually doing is we are communicating with this API server. So immediately we say kubectl get nodes, get pod in this namespace, blah, 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 blah. This API server just grab the request and immediately check up on this guy alpha. I need so. So is this etcd will now send it back to the API server. So once you send out the request back to it, like it's going to search in this database. Oh, kubectl get node. Okay, we have this node. The name is Docker desktop. It will send it to this API server. So API server now will now display it to us as we have it here. When we do kubectl get ports in this kube system, now display to okay, this is what we have. Yeah. So it is API server that will just give us the request. Immediately we make that request. Now, this API server, for example, when we say, okay, kubectl creates pod. When we are trying to create pod in our first class, immediately we make that request, this API server will do what? Will authenticate that request. Immediately you authenticate that request, this scheduler always follows API server, like you give it a close marking. Immediately you see that there is a request, like you want to create a pod, for example, or you want to create a deployment. It will now go and check each of this node, worker node 1, worker node 2, based on that request, which one is fit to accept that pod or those deployments, which one is going to affect it or accept it, or which one do we set it on? This scheduler will quickly go, pam, 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 go to this node, go to this node. Okay, it should be here or it should be on these 2 nodes. Immediately that scheduler does that, what he will do is the scheduler will come back to this API server and say, okay, Oga API server, I don't see space for you. This is the place you are going to what? Schedule this pod and this. So now, this API server now receive this message from this scheduler that, okay, oh, I think, okay, this is where we are going to. So this API server will now send that request to what? To this kubelet. You know, we said the other time that this kubelet is the chief of this node now. So once you send it to this kubelet, that, okay, kubelet, I know there's a space on you. We need this space, this pod to be created, this so and so. So immediately this kubelet will receive the request from API server. It will use the container runtime, which you have here, to create a container. Do you understand? It will create the pod. So once everything is done, it will come back. It will come back to the API server and say, okay, Oga, I've done what you request I should do. So immediately the API server receives it, okay, good boy, he has done that. He will now send the information back to the etcd to update the database. Okay, now this thing has been changed, update this database. So etcd now will now receive the database. So that's how it works. API server will authenticate any request that is coming, like the user interface, like kubectl get nodes, kubectl create pod, do all those stuff. API server will accept and authenticate it. It will check the etcd. Is this thing there? If it's not there, it will follow scheduler. Oh yeah, go and check for me what is available. Where we are we putting this? So this scheduler is always following this API server, like bumper to bumper. Like, Oga, do you understand? Following it bumper to bumper. So we get the request, go to this each of this node. Okay, this one is available. Bring back the request to API server. API server will now say, okay, communicate to the kubelet. Now do this, each of maybe this one or this one. The kubelet will what? Create the pod. You use the container runtime to create the container. That's why we need this container runtime. It's one that's going to create this container inside this pod. That's the function of this container runtime. So immediately everything is done, it will come back to the API server and say, okay, I've done what you asked me to do. I've carried out the instruction. Once the instruction is carried, so this one will now put it in the etcd. Remember, sometimes you are trying to do kubectl get pods and it's telling us no resources. So immediately we do that request to the API server. API server will come back here and check. It is I have not seen such. I have not seen such pod that this person is asking. I've not seen anything. What would this pod? API server come back to your guy with the resources you are creating is not what is not available. There is no resources in the namespace. Any resources? Do you understand stuff like that? So that's back into the architecture. And again, we now start talking about pod, how we create pods. So we create different pods yesterday to go about it, but in each of the pod, we create just a single, each pod has just a single container. So today we want to create a pod with many containers. Yesterday we are talking about, okay, let's have a pod, each container in a pod. But now, okay, let's try. What if we want to have many containers inside a pod? How are we going to go about that? And maybe we want to have 2 different applications, one inside a container, maybe to support the application. Maybe I just want to have my application running in this container 1, and I want my database to be in this container 2. So how are we going to go about that? So let's go to our command line. Now, yesterday we used yesterday I talked about 2 methods. We can use the imperative method or the declarative method. So the declarative method is when we have our file definition. We have a file definition YAML file, or we use it in just a command line to create what we want to create. But we know that the imperative method is limited, but it's just a fast way, and it's very, very useful in the exam because we have enough time to do that. So for the exam's sake, imperative is always the best. But when you come to your production, you know you have enough time, so you use more of declarative approach to do this. So we are going to use both method now. So let's start with so let's do the imperative method, then use it to create the declarative, generate our templates, then create it. So now let's imagine I want to, remember yesterday I talked about the reason why I'm using this K of 18. So sorry, why are you like this? Okay, come on. Okay, I talked about why I'm using K instead of kubectl, like I've turned into an alias. So I have my alias K equals to kubectl. So I'm using K instead of writing kubectl every time. So that's why I'm doing this. So let's do K run. Let's give it a name. So let's do test pod. That's the name. And we are using we are using an image called Nginx. Let's just use this. Let's use this image. Okay, we are using Nginx. So if I want to create it in imperative way, I'll just click on enter. It will create what? This for me. So K get pods, but you know that I created this in a default namespace. So I'm going to go into namespaces today too, so you're able to understand it. So now when I do my K get pod, I have my test running. Now, but you know this one now, the imperative method I created is just one container that is in it. I couldn't create what? Two. I couldn't create this pod with two containers. So you can see one against one. But let's do it in this way. So let me name it test2, so it will have a different name. Then let's export it to create a template for us. I said here we use oh sorry, what's wrong? We use dry run equals to, okay. So we use dry run equals to client. We want it in a YAML file. So it generates the template for us, right? So now let me redirect this template to a YAML file, test.yaml. So now let me open this YAML file. Can you mute your mic, please? Okay. So now we have opened this. We have opened this file now. Now this is a container. The name is Nginx. It will give it test2 because that is the name. It's just take the name of this what? This is our label. That's the name we want to use to create it. To create a label with it, create it. So here we can change it. So let's assume this is test1. So now we want to create. So the most important thing here is indentation. So now we want to create another image. Oh, oh, let me check for another image version of Nginx. So here we go to our documentation. You know, yesterday I explained how you use your documentation, right? But we still go more into it. There is something that will show us on this documentation. On this documentation that is very important. Okay, let's use this image. So the image we are using is image, this version, and what's the name? Let's test 2, right? Okay, I think that's done. So you can see these resources that is there. So this one is when we want to create our limits. We are still going to get there. When we want to create our limits, our memory limits, the CPU limits, that's for these resources. So it can be there, it might not be there. We can decide to leave it or not. It's just okay. So this is just item that is empty. So now this restart policy, it's always generated at default in always. Reason is because it's always so that when your pod goes down, it will restart, it will create the pod. So that's why this is there. It's always generated this at default. And this DNS policy is using the cluster DNS. So I'm going to talk about it when you get to the service. So what that is why is what is doing this for us. So I think this looks good. So now let's create this template file. Does anyone have a question? So our test port 2 is created. So let's get ports. So you can see that we have 2 containers here, 2 against 2, and they are running. So now let's try and describe this port. So okay, describe port test 2. Oh, sorry, that's it. Okay. So now we try to describe our port test 2. You can see this is in the default namespace. So it's using a default service account. We are still going to talk about service accounts. So this is the node we are using, you remember. So this is the label that is put on each of you. We are going to talk about label very soon. Status is running. This is the IP. So now if we go down to the section of containers, you will see the first one, container 1, which is our test 1. This is the container ID, and this is the container ID. You know, when this thing is running, where is this image? This container that is running inside this pod, whenever you run a Docker container, you always have a container ID. You have the image ID. They are 2 different things. So now that is why you can see here, you can see the container ID here as it's running. This is the image we are using here. So this is the image ID. Docker pullable. So this, you can put this image, we pull this image from Docker with this hash code. That's why you see this SHA. That's why we're able to put, you know, when you want to pull your image from Docker Hub, you might use an hash code. So this is what we use to pull it from our hub, from our storage. And I will quickly show you something also now. So now we haven't exposed it here, so it doesn't have a port. So this is state, this is for the first one. So we start count, doesn't restart yet. So it's working. Is it ready? Yes, it's ready. So this is where this one is being mounted. So you can see again, this is our second container. You can see this is the container ID, everything. So this one finished, muted. So do you have an issue with our container? Now you can see that this is a crash. I saw when I did the describe, I saw what happened. I just saw some network error. It crashed. So now what's the reason? So let's try and check. So let's do describe for true. Let's see if there will be a reason. but the first one is running, the second one is terminated. So in this case, what we just go and do is, let's go and get the logs on this on this pod. Kube logs on test 2. So now from here, we can able to know what is happening in our pod. We can get the log. So from there, we can see how to troubleshoot or what is happening. You know, when I created this, I just said, okay, let's just use these two different things just to show you how we create two containers inside a pod. So looking at this, I just checked through the log. Defaulted container test1 out of test1 and test2, yes. Not empty, attempt to perform configuration, looking for shell scripts, just looking at it. Configuration retrieve, ready to start. So this one is not, we haven't really seen an error here. So in this case, if you want to go further and see what is happening, we execute, we go inside the container and see what is happening inside this container. I don't know, do you get what I'm explaining, or it's becoming a magic? I want a response from us. Are you still with me?
Yeah, you are still with you.
Okay, and you are getting what I'm explaining.
Yeah, exactly. You're trying to like troubleshoot the error container.
Okay, okay, nice. So now looking at this, okay, let me do something. Get pod. So this, you know, when we created the pod, we put it in what's it called? We start always. So this is going to we start the container, and see, so in this container, it's telling us that it's only one of it that is working. The other one is what is not working. So let's what should we do? Okay, Control C. You can see that both are running again. That is the restart policy. So this one I just put it in watch to be looking at what. That's why I put this -w, so to be written at it the way it's one. So you see that it's running, it crashes again, it's recreated it. That's what I want to bring out here. And why is this thing happening? Because we put it in restart policy, the one I was showing you, the YAML file, always. So the moment it crashes off, it's what it creates it again, it starts running, it crashes, it creates it. Do you understand? So that's just the principle here. So that's it about creating, having, let me open it again and show us. So having different containers inside a single pod. So you can have many containers inside this pod, but it's not really advisable. Like, you know, look at this way now, the way we have it two now, like one of them we have an issue. It is very difficult. It's not that it's difficult, but we are looking at what will have happened, trying to troubleshoot. They don't want to affect the first container. And in case like this, when we want to, create the service, it might be kind of little complicated. It's not that, but when you are doing it in production, it might not be complicated. So that's why most of the time, it's always advisable to use just a single container in a pod. I hope you're able to get and understand the reason why I said so yesterday, like just use a single container in a pod. So that is it when it comes to pod. And we say pod is the smallest unit of a deployment. Now, before we go to deployment, let's go to another interesting thing, which is called the replica set. It's now bring out what I just explained now. When we call it replica set or replication controller. So now let's go to so this is everything we have on pods. There's still a lot. So when we go more into it, so we're able to explain about the pod. Remember, I told you that the injection, the storage, the container is ephemeral, so it doesn't have a lasting life. It's temporary. So let's go to replica set. Replica set and replica controller. So we have what you call the replica set and we have what you call the replica controller. So you can see this is replica controller, this is replica set. So what is replica set? Just from the name, you will be able to understand replica set. Like I want to create a replica of this pod on all the nodes, for example. Let's say, okay, I want to create the replica, create it so that why will you have to create this for high availability? Let's assume that one pod is down now, and we have our application in 3 different pods on 3 different nodes. So if let's say one pod is down, or even though node is down, our application will still be available to our users because we have the replica of it. Or maybe in a case in which you want to scale, that's why these Kubernetes just make life easy. Because when you want to scale, this makes it extremely easy. For example, now you have an e-commerce website now, like the one we have the Jumia. And you know we are going towards December, like say Black Friday. And in a normal day, the traffic that comes, maybe we have, let's say 1,000 traffic. So when we have 1,000 traffic on that website, 1,000 traffic is coming. And suddenly, maybe we have Black Friday or something just happened. And we have like 20,000 traffic in a monolithic application. What do you think will happen? Then we say that the server is down, right? Say that the server has crashed because we have what? A lot of requests that the web server cannot control. So in case of that, we have to go back to our application, start increasing, do many other things. We bring back our website again for users to access. Maybe after 2 days, users are not able to access, a lot of that. But in a case like this, you don't really need to be afraid of anything. Now, once you just set it, create a load balancer to it, when it is 1,000, maybe you just have a single pod. We have a simple pod running. If the traffic increase to like 2,000, it will create another pod and send the traffic to those pods based on the configuration, send the traffic those. So you can create like 10 different pods, the same pod, like a replica set of it, and send the traffic to them. And your website will just be running even when you have 1 million requests. So that's where we get advantage of what Kubernetes is bringing and what this replica set is bringing, replica controller. So it controls the number of replicas that you have. You can have replicas of your application on different nodes. So that is how this is working. So replica set is defined with field in core selector that specify how identify pod it can acquire. So the number of indicate how many pods it should be maintaining, and pod template specifying the data of new pods it should create to meet the number of replica in criteria. So if you say, okay, there is a lot of requests, it will create it, and if you want it to, have a replica of it running in different regions, maybe like that one is common in AWS. In AWS, when you're talking about region, you just want this application to be available to only the people that are from Europe. So when the traffic is coming from Europe, it will redirect to that pod. So when it's coming from the US, it will redirect it to another one. So another part of the application, maybe the multinationals that have companies all over the world. So if let's say I'm in Nigeria, I just click on it, it's going to show me the web page of the one in Nigeria. If I'm in Brazil, it's going to show me the web page of the one in Brazil. So this is how Kubernetes make life easier in that sense. So now, when we are creating, like in the way we create our pod, when it comes to replica sets, yesterday I said 2 things are important, 4 things that are important. The first one is your API version. And if you should remember, when we do kubectl API resources, it shows all the resources, like I said yesterday. It shows all the resources we have. Out of it is what? The replica sets. So you can see here, these are replica sets. This is the API version. You can see, so you see that it's different from, it's different from our purge or deployment, or I know which have an API version of this. So let's go back. So you can see the API version is this. What is the kind? You know, yesterday when we are creating pod, you said the kind is pod. In this case, the kind is what? A replica set. Then the third one we talk about is the metadata. So this is the one that contains all the information about everything that we want to create. So now we have the name. What's the name of this replica set I want to create? Front end. We want to give it a label. App to the guestbook. So the way this label works is, sorry, can you mute your mic? I don't know, someone just joined. I want to see if I can mute person. Oh, okay. So now we are going to go after this replica set, then we'll go to label, but we'll talk about this before we go about deployments, then talk about service and our service, and then our namespace. Okay. So now this is the label. So the label works in a key value manner. So we can see app guestbook. So if you want to name it, maybe in the imperative, when we want to do it, we do it, we see how it works. So key, the value, the key, the value. That's label. And what is the function of the label? Let me quickly use it to explain also now. Label is when, you know, you want to, you know, when you create a lot of pods, maybe you have 50 pods in your nodes, for example. And whenever someone in South Africa send a request, you want it to go to a particular pods. And when we want to create a service for that, you have to what? To label. So label is just like a sense of identification, just like the word label. I want to label this thing so that when I want to locate it, it will be easier for me. So if I want to create a service to it, or I want to create everything, I will just use that label. So whenever you see the label inside any of these pod, just go to that pod. So that's why you see that most of them has labels, just like a way of organization. Like I want to label this thing, like the way we do our labeling. I label this one, like you have maybe you have a shelf, you label it shelf 1, shelf 2, shelf 3. So everything, and someone is bringing something, and something that what is on it is shelf 1. We know, okay, this thing is going to shelf 1. Just like, you know, organizing your pods. You know, when you have a lot of them, it will be difficult for you to know, okay, which one am I, you know, controlling. That's where the label comes in. So that's the function of this label. That's what it's doing, and it's also in what? In the metadata. Now, there's another thing also we call the selector. So label, we also call it like a label and selector. They work like hand in hand. So selector is always used when we want to have replicas. Because when it comes to deployments, to, you know, I say pod is a single unit of deployment. Like just like in science, you say atom is a single unit of an element. That means that an element, you have several atoms. So the same thing comes into this area. So if you want to have a deployment, that means you might have one or more pods in that deployment. That means you are replicating those pods in deployment. So whenever you are talking, we are getting one than one, or even when you are even using one, when it comes to deployment, then you must come and use the word and use this selector. So now let's go to this. Let's see. So now you know this API version we are using. This is the kind. This is the metadata. So this is the now this is we want to go the specification for that container. What is it going to happen? So we now say, okay, in this spec, we have what we call the replicas. Say create a replicas of 3. So what is it going to create a replicas of what? Of 3 for us. So that's what this replica is telling us. So now we have selector. What is the selector now telling us? Under this selector, you now see what we call the match label. Like it should match the label of what? Front end. This type front end. And remember that we have, when we created this label, we have this front end. So we want to create it to match the label of this what? Of this front end. So when it comes to, okay, we explain that when it comes to deployment, like when it comes to deployment, you bring all this metadata inside what? The template. Like you can see here, okay, I can also explain. You see, when we want to create templates, everything that is in your metadata here, you bring it and put it in your template. Maybe I will explain that more when it comes to deployment, so you'll be able to understand what I'm saying. So, but let's go. So this match label must match with this label that is here. If this one doesn't match with the label that is there, it's going to give us an error. That's it will match labels, like matching the label. Like, I don't know if you get what that means. So you have to match the label. So from the word matching label, so you're able to get. So what is the label that I'm matching? This front end. So now, template. I want to create this template according to what is here. Like, give me this name. The labels that is there will be in the template. I will explain that more when we get to deployment. So more like everything that is there. So it's everything that is there, the metadata and spec will now be inside this template. That this template is going to be the template for each of the pod that you are creating, that you are replicating. But remember, the spec, this is the spec for the old words, for the old pod that is generating the old pod. But inside that pod, now I want to create replica. So each of the replica have what? Its own template file. So that's why you see this template and we are bringing the metadata and everything to in spec. So it's inside this spec now that you now define the container that you want to be what? To be there. So now this is the name of the container, PHP Redux. So now let's try and use this definition file to create. So this is just a pod. This is a pod. You can see this is a pod. Let's check. Okay, let's just use this replica. So let's use this definition file to create what? A replica set. So let's go to our command line. So can you see my terminal? Like, is it very clear? Okay. So let me do this. Let's do replica set.yaml file. So we bring this here. We want to create this replica and we have it in the namespace. Let's say defaults. Doesn't matter. Let's just do that. It looks good. So now let's create this replica set. So now I will show you something now. You said that the replica set has been created. Get pods. You see something. Now, when I did kubectl get pods, remember in my, let me do it like this so you can be able to see it here. Remember in my replica, I said create 3 replicas, right? So when I did get pods, I have 3 of it. But look at what is in front. That's what I was trying to explain yesterday. Now, if you see anything like this in front of the name, like this random numbers and alphabet in front of the name, you just know that they are replicas. They are being replicated. That's why you have this random number in the front of them. So now let me now do k get replica sets. Do you see what it gives me? It gives me like front end. That's the replica set that I created. Desire is theory, current is theory. Do you get the principle now? So it created 3 instances of this front end. The same thing, created 3 of it. That's why you have this 1, 2, 3 here. But the name of the replica set is 3 and this. Let's see. Okay, get pulse again as the container finished creating. So our container have finished creating is created, and you can see like they are running. And we have these 3 replica of it. That's replica set. So I can do k get rs. So let's do k describe to see, okay, what is going on here. Describe our rs. So it's telling us it's created in the default namespace. Remember the selector that we put this. So these are the 2 labels that we have for them. What created 3 is running. Tie this. So now let's quickly do something. Let's assume that it's like we have more traffic now, like a lot of traffic that I emphasized before. I thought it's going to be 1,000 traffic, but now it's going to be like 8,000. Like, okay, I thought it's going to be 3,000 traffic, maybe 1,000 for each of the pod, but now it's now going to 8,000 traffic. And that means I need like 8 pods. That will now bring me to another principle. Now I want to join it together. So I can decide to scale up this what's it called? This my replica sets. I can scale up replica sets. I can scale my deployments. I can scale my replica control. I can scale my daemons. Can we scale them? Okay, you can't scale daemons because they create only one instance. So I'm going to get there. I can scale them, maybe my stateful states. I can decide to scale them. So let's try that. So this thing, the more you go into it, the more you know some command that, okay, this should work, this won't work. And whenever you don't know it, you have your full documentation. Like, okay, before we go to that, let me do something. Okay, get rs on, you have an help on that. Will you give us an help? It's just going to give us k get. So like, for example, now I want to do k get. Maybe I've forgotten the next command that will be there. I'll just come here and do k get help. So looking at it, it gives me different suggestions. Say k get to get up pod, you do get pods. To get up pod in a wide, you see, with more information, do k get pod wide. So if you want to get a replica controller, do k get replica controller, then the name of the replica controller that you want to get. If you want to get it in JSON, so it's going to give you the suggestion on what you can do. So you just go here and do what you want to do. These are other flags that you can do, maybe not namespace on other. So the more you go into it, then the more you know more of your command, the command line. Okay, let me quickly use this. So like now, we want to scale our replica sets. Now, k scale replica sets. I do like replicas. Sorry, I'm very bad at spelling. Replicas equals to 3. Scale. Oh, stop. So I say scale replica, our replica set. What's the name of our replica set? Front. Is it front ended, right? It's front end, right? Oh, okay. So you want to scale it to, let's say, 8. So yeah, I want to scale up to 8. See that you say my replica set has been scaled. Now let me get for what will happen. It will, okay. No, let me show you so you see what happened. What happens? It created, it created 1, 2, 3, 4, 5. It created 5 more words. Instance. It's creating 5 more instances of that for me. So K gets RS. Oh, sorry. So now when we do K get RS, K get replica set, we now showed us that we have 8. But 3 is ready because the remaining one are still creating. Do you understand? But now I want to show you something like the limitation of this imperative method. Now, if you check the definition file of this front end, you will discover that it is still 3. Is it? Let's check. So now we can use K get it in a YAML file, or we can edit it. Okay, let's do K edit replica set. Because it is the only replica set I can do this, and it's going to open the replica set for me, but it's just to have a good practice to always give it the name. So I want to edit this replica set. Okay. So when I edited this replica set now, okay, now it shows that it is 3. It's 8. Okay, I think this updated it. So it shows that we have 8 replica. Initially it is 3. Now we have 8 replica sets. Or maybe I just want to I don't want to edit it. I want to get it in a, oh, sorry. Instead of me to cancel, I did change, but no changes made to it. So maybe I want to get it in a YAML format or in a JSON format. I just do K get replica set front end. So get it for me in a Word YAML format. You can see this is it. I can redirect it to another file. Maybe I can redirect it to another file. Can you see it's there? I can redirect to another file. Maybe I want to use it to create another definition of stuff like that. So now this is what scaling up. Yeah, are you with me? So this is scaling up. What if I want to scale it down? Just like what we did. So let me scale it back to 2. So my replica front-end scale, what will happen? K get ports. Who will tell me, who can tell me what's going to happen? Anyone?
We'll be left with 6 ports now.
We'll be left with 6 ports. Okay, any other person? Any other
sorry,
person?
2 ports. 2 ports, sorry, 2 ports.
Okay, nice. Any other person? Any other idea what's going to happen? So it's going to, what I want to hear is that it's going to terminate all other ports that is going. Oh, you didn't see it. I want us, okay, it's already, they have terminated before we can check. So it's going to show that it's going to terminate all others and leave us with 2. Do you see how easy scaling is when it comes to this? Look at how Kubernetes make life in just a single touch. You can scale up your application, just a single touch and a single command line. So you can't see any issue or have any issue. Like, our application is down. Let's go and maintain it 2 weeks. Let's call all our developer. What is happening? We have too much traffic. You don't really need that. You can just set this one, just go to bed, and money will be entering. So now I want to show something. Because we are using Docker desktop, I just want to show something here. Because we are using Docker desktop. So everything we have been creating since, you can see the pod here running. Look at the engineers we created. Right, okay, these are our old ones. These are our old ones. So this is the one, this is the pod that created our controller that created our, what's it called? That created our kube control manager. This is the one for our API server. So this is one for our kube scheduler, kube script processing. You can see them. So just want to show this anyway. So this doesn't really have, sorry. This doesn't really have elements. So let's just quickly check replica controller. So it's just the same thing. Replica controller. Before we go to deployments, then service, then namespace. I hope we can be able to. Oh, replication controller. I'm bad when it comes to spelling. Sorry. Okay. So just like what we did in replica set and replication control, just what we did in replica set, the same thing we are doing here. You can see that it's the same thing. But who can tell me the difference in this and the replica set we did? Can anyone just point out to the difference? Anyone? I'm waiting. Any? Want to try? Okay, no reply. So if you look at
okay,
this,
can I say something?
okay.
Oh, what I feel is that when it comes to labels, like you labeling your pods, it's quite different compared to replica sets. Like replica sets quite different compared to a replication controller.
Yeah, nice. So 3 things are different here. The first thing is your API version. Remember in replica sets, we have this as API version, but in controller, we have, oh, okay, I think I opened this. We have this human. Let me close this. So the kind, of course, will be replication controller. And here, like you said, we don't have the label. That is the reason why we don't see a matching label under this selector. So those that are doing CKAD, a scenario like this will come up. They might give you, like, if you find an error in this definition file, we can maybe give you this definition file now. They will change this one to the version of a replica set. Then this one will be in the replication controller, and they will put a matching label there. They now say, okay, if you want to create this file, it's going to give us an error. Let's try it out. It's only when you try and get the error, that's when you understand what you are doing. So let's try it out. Let's do vim rcc.yaml. So now let's do it. Let's create a replica controller now. Then we make this one apps slash vi. You know, this is replica set, right? This is the API version for replica set. Okay, let's just use it and try to. I think this one too should be enough. So let's try to create this and see what it's going to give us. Hola, is saying resource mapping not fun for name, engineers, namespaces, for kind. So it's already, they have given you what, where the error is coming from. Like in version this, they have already told you what the issue is, where the issue is coming from. So you know that, okay, it's like this Oga is the one that is having issue. Let's just use this one and just, okay, I quickly fixed it. Let's try and create it. I fixed the error. So we have a replication controller has been created. Okay, get ports. You see, this is the Nginx. It's creating 3 of it for us because we use the Nginx image. It's created this for us. Let's get sorry. So, you know, we have replica set, that's RS. You see now, I'll see the same thing as that. So let me do get all. Oh, sorry. I just need to do get all. So this shows us the pod. So I'm getting, or these are all the pods. This is the replication controller that we have. This is the service. Note this service, they are what? They are default service. So if you don't create a service when you create your pod, you are still going to get there. It's going to create a default service for it, which is always the cluster IP. We have 3 types of service. We have the cluster IP, the node pod IP. Then we have the third one, which is load balancer. So those are the 3 that we have. So you can see here, I think maybe the one we copied, it was being specified. Yeah, it was specified in it. That's why I created a one for node pod, because we put the container port. Whenever you put a container port, it always creates a node port for us. Whenever we don't use a container port, we are going to create a cluster IP, or we can create a load balancer. We are going to get to service very soon. That is why it's getting to. So you can see our replica set. We have 2 of it as we do. So we can do the scaling up and scaling down for this just as we do for our replica set. So I think that is clear. So now let's go to what you call our deployment. Yep. Now, what is deployment? So deployment is just like when you say you have a system that manages okay, I'm trying to look for like something to use. It's like I'm looking for, I have a system that controls so and so. Okay, this is just deployment is a system that controls your pod, your replica set, your replica controller, and co. So what is this deployment? Provide declarative updates for pods and replica set. So it's the one that just, it's just not something special, but just like I use that definition of an atom, like an atom and an element. Element controls all the atom. We have a lot of atom in it that it controls, stuff like that. So that's exactly how this deployment works too. So you just want that, just a system that controls it. So now when it comes to deployment, you see, let's go back to the 3 things that are important. The API version, the kind, then we'll come to the metadata. So the metadata, like this is the name of the deployment. Then this is the label. We are giving it. Now I talk about label 2 before. Then this is spec. Just like what we did in our replica set is the same thing in our in our deployment. But most of the time, it always makes sense when we create it as a form of a deployment instead of like a replica set. So now, as you can see, like I explained, this is the replicas I want to create. So this, the selector. Now you can see this matching label is here again. It's similar to what the replica set, which is not in our replica controller. If you can see it there. So this is the matching app, Nginx. It must be the same with this. We are going to try it out now. We are going to change the matching label to another thing and see if it's going to work. So it's always good to, when you want to do, or just try all this thing out and see. So I just want to change this. Okay, let me just remove one, just change it to Nginx. You know, they're not the same now. So I'll just want to change it to this. Then just like the way we create our definition file, okay, create F. We can see it's telling us invalid metadata label. It's telling us that is this label, this spec.template.label. It's not telling us that the selector does not match template label. So that is it. So it must be the same thing. So I want to do something here also now. So just like we did, let's create our deployments. So now I've created this deployment now. So okay, get deploy. I can use deployment. I can use it in a small shot to like deploy. So they are still the same thing. It shows this is the name of the Nginx 3 are available. Okay, get pods. So this is the Nginx deployment that we have. So what if I want to edit this deployment? Maybe I want to change the name. You can also do that in pods, so you can do it in any of it. Okay, edit, deploy. Because it's one. If I click enter, oh sorry. If I should click enter, it's going to open it for me because it's one deployment. But if it is two, it will give me an error that I should give the name of the deployment. So let's assume I want to change the name of this deployment now to Nginx deployment 1. Oh, sure. 1. So, you know, it will be open in a text editor. Then I do like this. It tells me that okay, sorry, let me try and do something again. I will get back here. I think I don't know if I did something in this place when I was trying to use the command. Okay, let me just do it. But then I'll still coming back here. So I changed the name of this deployment, right? It's telling me an error. It said a copy of your change has been stored in this error. At least one of the API version kind and name was changed. That is why it's giving that error. That means it can't make a change to this definition file. But I want to make a change to it. But it told me that this thing has been saved here, right? So what I will just need to do is to copy this. Then come here, K replace F by false. So what this is going to do is it's going to delete the one I have, then it's going to replace it with this new one. So it's going to delete this one and it's going to replace it with this. But I can't do it in the edit file. But if it is a pod, I'm going to try a pod now and see. Then I say, I want you to replace this, you know, you just give it its own name. Everything is in this. Okay, let me do something before we do this. Before we do this, let me do less so you see what is in there. You can see this is the Nginx deployment 1 that I edited. So this is it. Okay. So now let me do what I want to do now. K replace F force this. So K replace what I'm using this, if I want to force it, force -F, what I'm doing is I force it. So that means I make it delete this one and create a new one for me. So you can see that deployment, it tells me that this deployment, this replaced. So now let me do get deployment. You can see here. Do you get it now? This is the new one it's created. This is the new deployment one. So this is the other one. So let's assume I want to edit this pod. Now let's see if you can edit this pod. Edit pod, new pod. So let me change it. Okay, let me just change the label to new pod, new. Let's just use something like this. I can edit it. I can edit the label. Let me see. I should be able to edit the label. So now if I want to do get deployment now, oh sorry, edit deployment now, it will give me an error. Why? No. Edit deploy. Okay, it's still one that is there. Get deploy. So we have to. It should try to tell me that I should put the name of the deployment there. So that's what I want to bring. But that doesn't mean get deployment. Edit deployment. Copy. Paste. So let's try and change the label to maybe one, just something as default. I can able to what? To edit this. So there are some things that I can able to edit in the deployment directly, and some things are like something like the label that I'm giving to it. And when it comes to like the name, the container image, I might not be able to edit it directly like that. So that's why sometimes we get it in the YAML file, then we replace it. That's where the replacement comes. In that area, do you understand what I'm doing there? Do anybody have any question?
My question is about the replace command you use, because I noticed that the replace command recreated a new deployment. So you said if you edit the container image or the name of the pod or the deployments, is going to change. You're going to use the replace command for it. So my question goes those: is it going to create a new deployment, or it's just going to edit that whole deployment?
So do you know the reason why we have two deployments here? Is because we edited the name. That's why it's seeing it as two different names. Do you understand? So let's do something like this. Edit. Let me try the last command I use. So let's edit the image to another thing. If I use BC box, it's going to crash. And I'm going to tell you, I'm still going to tell you why later. So if you are using BC box, then we have to put it like, we have to put an argument for it to sleep. But I'm still going to explain that. I have a place I want to explain that. So let me use Redis. Let me use Redis as the image here. Is it Redis or X? I think it should be X. Okay. Okay. So yeah, I could able to edit this, but this is not what I want. I wanted to replace this. So, okay, this is what I should have done. Okay. Get deployment of this. So let me get it in a YAM file. So now I will redirect it. So let's do replace.yam file. But before we do anything, okay, get deploy wide. You can see that this one is using a container Redux, right? And this is the name. So what I want to do now is I want to change this one back to Nginx. So now let me open the new file that we have. That's replace.yaml. So I won't change this deployment name. So it will be seeing it as this. I'm just going to change the image. Oh, is this? Oh, I only changed the name, right? Okay, I thought I changed the image. Okay, it doesn't matter anyway. I thought I changed the image. That's the name, but it doesn't matter. Let's even use another name. Let me even try to use my name. I change it as the container name. So now I want to replace this like what we did earlier. So K replace force F replace dot YAML file, right? Do you see what happened? It deleted this and it replaced it with this. Unlike what we did the other time, because we changed the name, so you see different. So even when we do replace, it's going to create it for us because it's not seeing anything to replace. There's nothing in the name before. So now let's get the port wide. You can see that it has deleted the other ones and created a new one for us. It replaced it. Now, do you get it now?
Yeah, thank you. I
So
understand
it's
very well.
because I use different name. So it's not seeing something to replace, just created that one. So that's why the deployment is here. So let's do get off. Now we are going to see, like, look at, to create, like I said, it's going to create a service. So we're going to be going there now. Declare the deployments for us, this one and this one. That's that. Oh, I hope we can be able to get, okay. So now let me quickly show us label. How to label. So if you want to label, you can just do K label. What do you want to label? Deploy, that's deployment. Because I'm used to that's why I do shortcuts. I want to name this, or I can just copy this. Copy. Label this. So what this one is saying is that deployment.app, this is deployment / this is deployment name. I can also click as K label deployment space deployment name. It can go in any way. K label this. So what is the name I want to give to it? Let's do name equals to Shegun. That's the label. It's going to be like a key value. I think it should be in a quote. Okay, labeled. So now let's do K get deploy. Let's get it in a more wider space. Okay, let's do K describe deploy. Which one do we name? I think it's this first one. because I'm expecting it to give it the label. Okay, so you can see that in these labels, when we do describe, look at label. It also labeled this as this. It has labeled it. So that's how you label. You can label your deployment, you can label your namespace, and this will be very useful now when we go into the area of namespace and other. So when you go to service, you understand why we are even doing this label. What is its usefulness? So that is all about label. So I want us to go into service quickly. So we came late, like we started 15 minutes late. So it's possible we might use some time, but let's see. So now I want to call about service. From the word service, like I want to serve you, right? Like something like that. I want to explain the concept for us. So when we see the concept, you know what we are doing. Like service, I'm serving you, I'm serving you, I'm serving you. So let's see it in a way that maybe I'm in a restaurant. I'm a barman, so I'm serving this person, I'm serving this person, I'm serving this table. You make your request, I'm serving. So I'm like the intermediate between you and your request. So if you go to a restaurant now and you say I want to eat chicken in the restaurant, you don't know where the chicken is, you don't know the price, you don't know how to serve it or that, because you are just coming to get it. So I'm the service that will I will take your request to where it is, where it's supposed to go. But then before I can go there, I will have to establish a sense of communication. So the main purpose of service is just like is establishing communication. So how is it establishing communication? Why are we communicating, and why is the service even useful? Why should we need you? What's your essence? Now you know that when we create this container is running, okay. When we create an image, our application, when we put it inside an image, and we try to put inside a Docker image, for example, let's assume we are using Docker image. Do you understand? You know, when we create a Docker image, we expose the container on a particular port. Maybe we say expose. When you are creating Docker commands, there's something we call expose. Like from when you are doing the Docker, when you are building the image, I don't know if you are familiar with what I'm saying. From so copy, run this command, expose, you say port 80. So that means this container here is listening on what? That port 80 that you gave to it. So looking at this now, this is the service. It has a load balancer, like I said, it has a node port, and you have the cluster IP. Then we have what's called the external name. So you can create your own external name. Still coming to that. So now, just looking at this, you see that this container here, it has its own port that is communicates. This port 2 has its own, this container, this port 2, it has its own IP. So whenever you want to go to this port, this container, if you know this port ID, you say this IP 1.2, let's say 172.16. This semicolon 80. 80 is the port that this one is listing, is being exposed to, this container. So if you do 172.16.11.1.1 dot, what is this? Column 80. If this is 80 and this is 40, say dot column 40. Maybe you want to go to this container, I want to listen to this container. Listen to this one. So this port has its own IP, this one has its own IP, this one has its own IP. They're in a port. Maybe your application is there, your database is there. You want this one to communicate with other. That means this pod must listen to this pod. Must be able to communicate between this pod. And again, when this API is sending your request, or maybe there's an external request that is coming to this, you must be able to communicate with the old node, then have a communication between the pod. They should have like is like a community. They should be able to communicate with themselves. That is where what service is coming in. So service is the one that established the communication between the pod, the whole cluster itself, and between the external user. Because when you start sending requests, like when I make an example the other day, maybe you want people, only people in Nigeria to view this website, you want people in Cameroon to view this particular one, you want people in maybe in Germany, people in Sweden to view this particular. So we have different, because so it's just the balancer that we distribute this request is going to this, and it's doing that through the help of what? The service. So whenever you create your pod, your deployment, you have to expose it in a with the service. That is the service you expose it. So it's that service that we use to what? To communicate with that pod. You can see the other time when we are trying to do is creating a default service for it instead using a cluster IP. So we have to what? Expose it to in our own what? In our own service that we want. That's where this service comes in. So now we have 4 types. Like, so I will start with this, which is the cluster IP. So before we go into it as creating this service, excuse me, we have the what? Cluster IP. Excuse me. So we have the cluster IP. So this cluster IP is just like in a, in a whole cluster, we have the worker node 1, worker node 2. So there is this cluster IP, which you can see here. This node has its own IP. I mean, has its own, let's say, as a port. Let's say there's a port in which this node is listening to, and it's within the range of 30,000 to 32,767, I think, if I'm right. Like I think it's from that range. So whenever you see node port, you see like when you look at this, you see like there is 1, 2, 3, 4, 5. No, okay. You see that it's like 30,000, like always 1, 2, like 5. So like this port is like 80, but its own is like from 30,000 to 32,000. So it's within that range. That's always the node port. So now this port has its own IP. Yeah, and it's listing, it might have a port that it is listening on. Now, this node 2 has a port that is listing on with an IP that is there. So now, when we have this, let's just use these 2 nodes first. The one on our screen, we have these 2 nodes. This cluster IP established the communication, like it will establish the communication between these 2 nodes, that whatever you make a request, like when we do 192.68.1.1 dot, I mean, sorry, not dot, column, let's say 8080, for example, now, it's going to bring us to that particular port that we are requesting within that cluster. Like it unifies all the nodes that we have in that cluster together and give them a particular IP that is resolved to a particular IP in which both of them can communicate together. I don't know if that really makes sense. So that means there is one IP in this cluster that make requests available to this worker node, to this worker node. Now, compare it now to our node ports service. This is the user. So this user is making a request. Look at 2 different requests here. This request XX, this request XY. So now when they are making this request, this node ports, because you can see here that they don't have node ports here. Instead, they have a cluster IP. That cluster IP is what will take the request of the user to which of the node that will answer their request. Do you understand? But in this node port, each of this node has a port. This is port 1, port 2. So when this request is coming excess, it will direct it to this node because it will go to direct it, because when we use this ports here. Maybe we say 30,200 is the port that we use here. So when we use this 192.168 maybe .1.2 that port request, it will bring it to this node port. Like you want all these requests here to come to only this node. Then we use a node port. But look at this XY. This request, this service will route it to what? To this node. But in this case, we only have the cluster IP. So the user has to use the general IP. So they were able to interact in this what? In this cluster. You can see in this cluster IP, you can see what we call the kubeDNS. So that is where this area, I said this area, don't mind. This guy comes in, KubeGet ports. So that is where this guy comes in. So in this scenario now, we are using what we call the core-DNS. There is a way we can create, we can use different type of data, but here we are using core, sorry, no, it's not code on my, sorry. We are using core-DNS to create the service here, like in this Docker desktop, in this Kubernetes, we use core-DNS. You can see, we can use another types of DNS, so don't be confused. But once you understand the principle why we are having this, then you know what is in and why we are doing this. So the main thing is to understand the principle behind this. So now let me just explain this principle in a layman's term. You know, when you have, okay, let me explain this in a layman's term. So when you have your front, like a web developer now, we have your front end, you have your back end, you have your database. So let's assume your front end have like 10 instances, just like what we did now. You have 10 different instances. Your backend too is like 10 instances. Your database is like 10 instances. So you can bring all the database together to communicate, have a unique communication with it, like creating a cluster, like bringing cluster together. That is cluster IP. That's what this cluster IP, you bring all your applications together, they interact with each other. Whenever you have microservices, you have the sign in, the login, this and this, you bring them together. So that is that. So when it comes to this node port, like you only want all these requests to go to this particular node. This also to go to this particular node. So each of the node will have their own port in which they will listen to it. If the port is not stated correctly, it will not go to any of these nodes. But maybe the port here is, let's say 30,200, this one 30,300. If the user uses 30,200, is the the service is going to bring it to this node. If it's 30,300, it's going to bring it to this node. That is that's the difference between the cluster node and node port. So when you create a default deployment or replica deployment in this, you can see that the default that is given us is what? The cluster IP. That's the service it creates for us. Now, another type we have is what? The load balancer. So this load balancer looks like the one we have in the, what's it called? Our node port. So this load balancer is just, you can see, it almost looks like the same thing. So when the user send, the only difference in it is that this user have to specify the node that they are going. That's why you can see this user have to put this node here. But here, the user doesn't really have to put any IP. It's just the default IP. It's going to take them to this cluster. But this node, the user have to specify, like, I'm going to, that's why you see that this IP here, which is this service that is here, and this node port. But in this case of load balancer, the user have to use the default IP, like 192.this, maybe that's default IP rather, and listing on this port. So when they're listening on this port, so the load balancer will take the request, and inside the cluster, this at here, this happens outside the cluster. The user specifies outside the cluster. But here, they specify outside the cluster, but inside the cluster now, the service now routes it to this. We now take it to this node port, depending on where the request is going. Do you get the principle? Hello? Are you still with me? Do you understand what I'm trying to explain?
Yes, sir.
So the same thing when it comes to this external, the only difference here in the external name is that you are the one that give this service your external name instead of using cluster.svp, using the cluster, you are the one that will create this your external name yourself. So the cluster will not do the what's it called? The cluster will not be the one to create or generate the service name for you. You are the one that is going to create it. That's just the one with this external. So now I quickly want to talk about this DNS naming convention, this element domain, if you don't know about it. So whenever you make a request on your system, www.google.com, for example. So this dot is specify the root. This is very important in DNS, so you're able to know what is happening. So whenever you make that request, your request will go bam. It will go bam to this dot. So when you get www.google.com, you'll be like, I don't know this website that you are requesting, but I can direct you to where you can get this. Someone that have an example. For example, maybe I want to buy tilapia fish. So when I want to get tilapia fish now, I just go to a market. Like I want tilapia fish. Someone will say, I don't know where to get tilapia fish, but I can direct you to a store where they are selling fish. For example, can I use that? Okay, let's assume we want to buy okay, let's still use that. I hope it's going to last long. So it's now going to direct you to .com because you said www.google.com. It's going to direct you to .com, which is the top level domain. So .com will be like, I've seen I am .com, but I don't know where you are going. But I can direct you to that place. So when you get to the place, maybe the market where they are selling fish, I can direct you to a specific store where they are selling this tilapia. But I know this is where they are selling fish, but I don't know where they are selling that tilapia, but I can direct you to it. So this .com will now direct you to the subdomain, which is what? The www. I'm just using that one as an example. Like the google.com, it now take you to Google. Like, do you know this? So when now take you to the store that they are selling the fish, now open the freezer where that tilapia fish exactly is. That's okay, it is part of it. So you can see I say example.com. It said the mail.theexample.com. So like in Google, we have app.google.com. You have mail.google.com. So you have www.google.com. You have drive.google.com, stuff like that. So those are the subdomain. So from here, you can see the cluster.theexample. So now this is the host name. Like let's say this is node 1, it will be that node name the cluster.example.com is going to be the service name that you're going to use to connect to that node. And if you are creating your own external name, then you try to change this name .com. It can be or maybe this is in internet space, maybe a government website where we are using .gov or .net for what they use .net for, I don't know, maybe .edu for education, .com for the general public, .gov for government and stuff like that. So that's how DNS works. And it's the same principle that DNS works in these clusters too. So now let's go back to our command line and see how is this service created. Before, let's first go to our favorite page, which is always our documentation. I know documentation for those that will be writing the CKA rather. So you have access to the documentation in the exam. So the thing is to know how to use the documentation and have access, to the document. I mean, to know how to access and make use of your documentation whenever you need. Although you can't be creating deployment and service using your documentation most of the time. Most of it you create it using command line and code. But once you get used to it, you know how to edit what you need to do in it. So let's look at this service now. We create this service. This is the API version as usual, kind service, metadata, this is the name. And this is the spec. So inside this spec, we said the selector. Now this selector, the job of this selector is creating the service for this my app. And where do we get this my app from? Is the label we gave to what our deployment or our pod that we created. Do you now understand why we are using the label now? Because if I want to create this service, I don't know where I'm just create service. Service for what? Maybe I have 100 pods now. I want to create service, like I just create service for which one to which one. So now this is where this selector. So when I've labeled my pod, now that is where I will use the selector here now. And I put this label here. So look at the service is the REST objective. When you're talking about REST API, the REST object, similar to a pod, like of the REST object, post service, definition of it. So for example, suppose you have a set of pod where each listen to TCP. So in our pod, remember when we created one pod, we give it container ports, we give it 80, if you remember. So let's assume the port is this and have a container label of this. So this is the label. You remember the other time I do name Shegun as a label, name equals to Shegun as a label. So if I want to create a service now, so let's do something like, let's now create this service now. Then I will now put the label of the one I created the other time and put it to it. This is a pod. You can see this is a pod. We created this pod, give it this label. Then we created the service using this. Show port. Let's go back to our command line. Is it still okay if I take like 5 minutes of our time to finish this service? Is it okay? Hello?
You can go.
Yeah, you can go on. It's okay.
Please, if not, just let me know. So I just want us to finish this. So that means we won't be able to go to next space except you want us to. The other time I said name equals to Shegun to one of the deployment. I don't even know. I don't even want to know now. Do you understand? I just want to go because I remember the label offhand. So I want to show you the power of that label and why we are using that label. So let me create this service like this. Create F. So the service has been created. Now let me get kget all. I can do kget service. So this is my service. This is what is listening to. I want to show us something. Kget all. So when I did this deployment, so I've forgotten the one I actually label as that. So let me do kget ports. So wide. So I've forgotten the one I label, like I give the label Shegun to. Honestly, I can't remember. I know I labeled one with my name, which
I think it's the first deployment you created. So you changed
deployment,
the
right?
label. Yeah, exactly.
Deployment. Okay, let me get deployment. Container. This is the label. I think it's one of these deployments. Let me describe this deployment. Okay, so describe, deploy. Oh, no. Okay, describe, deploy. But this works mostly on Linux. Oh, okay. I did a mistake. Sorry. Okay. Is it this? Okay. Yeah, is this deployment, right? Okay. So now, get service. Oh, sorry. So this is the new service I created. My service. This is the what? The cluster IP. But let's assume I want to create a node port instead for that deployment. And now we are going to even be using imperative. We won't be writing a definition file. So, to do that, use expose. Because let's now expose deployment 2. You know, we exposed deployment 1 at engineers deployment 1, right? Expose deployment. I haven't shown you how to create deployment with this imperative method. I'm going to show it after this. I'll quickly do that. Expose deployment. What's the deployment name? Engineers deployment 1. This is what I want to expose. But I want to expose it on ports 80, for example. Then you set the target port equals to, let's say, 80. Then cluster IP. Do I get this correctly? I'm not sure, but let's try it out. No. Okay. I don't need to disturb myself. Let me just go and do help. I've forgotten that command. I think it's still the same thing. So what I'm looking, this is what I'm looking for. Okay, let me go up. Okay, target port. I'm looking for the node port. Yeah. So okay, yeah, I remember. So with this definition type, I cannot add. I should be able to add it. Yeah, this cluster IP. Yeah. Load balancer. Yes. Let's go to node ports. Oh, so I can't add the node port here with my imperative command. So this is what I want to do as initial. So I can do, this is what I want, I was doing before. So let me just copy it. Then we'll put it in a drive run. Then I will go to our documentation and show you how to include the node port to it. So let me do this. Create the deployment. I shouldn't have erased this. This is Nginx deployment, right? Just a minute. I want to copy this. Okay. Paste. So expose Nginx deployment at this port. Let's say the target port is this. Then let me give it a name for our service. So give us a new name. Let's say new service. Let's just write it together. New service. Okay. So the service has been created for us, and we give it a new name, which is new service. So let's do get service. Oh no, this is not what I want to do. This is not what I want to do, but okay. This is not what I want to do. So we can see this new service is there created. So but this is what I want to do. So we can just give it a new name. Okay, let's do new service 2. I want to make it a node port instead. That's what I want to do. So I've forgotten. So let's join on equals to client. Let's take it in a YAML file. So this is our new service that we want to create. So let's redirect it to a YAML file. So let's open the YAML file. So now let's go to our documentation. So now we want to see how we are going to add a node port to it. So I think we should have it here. So look at it. Under our target port, so we just add this node ports. Come back here. So it can be anything. So let's just say it's 30,007 or maybe 30,050, anything, depending on the node port you want to use. And I do this. If I should do this, let me go back so I can replace. I can replace it with the first one, so I don't need to create 2. So now, so what I will do is replace first. F is going to delete the first service. So you can see that the service, no service is invalid. Spec port, no port forbidden, may not be used when type is cluster IP. So it has deleted the first cluster. So let's go back to our definition file. So now let's go back to our documentation. I will show you something. So why this is a port, target port. So in our spec, so the reason why it's giving an error is like in our spec, we have to specify the type that we want. So I should have done this in our imperative command. So like, okay, I will do it again. I will use another name to create it again. So I should have used type equals to node port. So that's why I give an error. So I should have told this guy that I'm using a node port, but it wasn't there. That's why it's saying, it's giving this error that, okay, I will go back to the error now when let me edit this. I hope I got this indentation correctly. Yes. So that's why it's giving me this error that the new service is invalid. Spec.port, no type, forbidden, may not be used type is cluster. Because the default is cluster IP, and I've not specified the type. That is why it's telling me that. So now let me recreate. So since it has deleted that, even if I use replace, it's just going to create it because it has deleted it initially. So let me get service. So our service is SVC. You can use SVC as a shortcut to get service. So you can see that the new service now is node port. And this is the port that we specified that the port is leaving this into. So if I want to access that now, that's where I'm going to the area of the namespace. Now let me just go to this this and see. Let me just try and see something here. Okay. So if I want to access this deployment now, so what I will do is I have to use this, this port 10111.177 dot 80 dot this or dot, I mean not dot, sorry, forgive me, semicolon 30,500 to be able to what to access that. So, but for this one, I'll just use this IP then dot 8080 to access it because it's a cluster IP. I hope you understand me. So I think our time is fast spent. Let me check. I think we should stop now. So I hope I thought we are going to reach the namespace, then I will be explaining more, but I think at this stage, let's just stop for today. So we'll continue next week, Saturday. We start with namespace and then we'll continue with that. So I hope you are able to understand the teaching. Does anybody has a question or a concern? Anybody? I think I can stop recording now.